Okay. Hello everybody. Welcome back to Algebra 1. Um last time we talked about the basics of lines and stuff like that. Slopes. This time we're going to be talking about systems of equations. Now, systems of equations are really important in competitions. So, systems of equations are many equations with many variables. So, let's get into it. Say we had two variables, right, and then two equations. So we had, oh, frick, poop. 3x plus 2y equals, this thing, 4. And then we had 5x plus 4y equals 6. How can we solve for x and y? X equals what? And y equals what? We don't know. We're gonna solve for that. So now let's say we had 3x plus 2y equals 4, 5x plus 4y equals 6. Okay, so how do we do this? I'm gonna go over many techniques. The first technique is substitution. Elimination. And graphing. Hey, we know graphing. We learned that last time. So, we might not get into like squared and to the x and God, that makes me want to puke. That part really ugly. I don't even know if we're gonna cover that ever, but we might. So, substitution. What does substitution mean? So substitution is where we solve for one variable in terms of the other. Like for example, x equals 4y over 2 minus 3. Okay, then we substitute that into the other equation. So because x equals 4y minus over 2 and minus 3, we substitute it in the second equation for x, and we get, yeah, blah blah. I'll demonstrate it with this. So we have 3x plus 4y, or 3x plus 2y equals 4. 5x plus 4y equals 6. If we were to solve for y in the first equation, then we can plug that into the second. So in the first equation, y is equal to 4 minus 3x. What is this doing? Let me like turn off into shape. Okay. Now, y is equal to 4 minus 3x over 2 in the first equation. We can simplify this into slope into a better form. That's equal to negative 3 halves x plus 2, right? And so now we can plug that in to the second equation. Because y equals negative 3 halves x plus 2, we can plug that in. So we have 5x plus 4 times y. But because y equals this, we have negative 3 halves x plus 2 equals 6. So now, to solve this, we get 5x plus, we distribute negative 6x. So let me write that out. Negative 6x minus 6x plus 8 equals 6. We have a common x term, so we simplify that. We get 8 minus x equals 6. Obviously, x equals 2. But we're not done yet. We need to solve for y. So because x equals 2 and y equals negative 3 halves x plus 2, we can plug that back into one of the equations, or we can plug it into this definition, and we get y equals -1 as our solution. Now, some equations, you might not want to do this. You might want to do something called elimination. Elimination is where we do operations with both of the equations. So, I'm gonna remove all this. So, now we're gonna solve this by elimination. Elimination. So, we solved it. What's happening? Okay. Well, we solved it by substitution, and now we're gonna try elimination. So, elimination is where we make one of the coefficients, which is a number before the variable, one of the coefficients of one equation the same or the negative of the other. So in this case, if we multiply by 2 on both sides of the first equation, we're gonna get 6x plus 4y equals 8. Then we also have 5x plus 4y equals 6. So now, because 6x plus 4y equals 8 and 5x plus 4y equals 6, we notice that these both have a 4y. So if we subtract both equations, if you subtract the second one from the first one, this becomes x, and then this becomes these are gone. 0y gone, and that's equal to 8 minus 6, which is 2. So x equals 2. If we plug that into one of the equations, we get. So if we were to use 3x plus 2y equals 4. So we have 3x plus 2y equals 4. Because x equals 2, we have 6 plus 2y equals 4. Solve for y. Y is equal to 4 minus 6, negative 2, over 2, negative 1. Elimination is just adding and subtracting equations and multiplying equations by things so that you can cancel out one term, and you just have a simple linear equation. You can solve for just one. So we got that correct. Good. Now, the hardest and most tedious one is graphing. Graphing is where we just... God. Graphing is more like... I mean, you usually don't use it when you have 3 variables like x, y, and z. Usually only use it with these 2 variables. Also, notice that when we have some amount of variables, let's say we had n variables, we need n equations. So in this case, we have 2 variables, x and y. We need 2 equations. So, yeah. Now graphing. So we use elimination. Good. Now graphing. Graphing is a little more annoying, right? So we're gonna get a graph, right? I'm so glad I have graph paper, because then you have to God. I mean, gosh. So now, wait, 3x plus 2y equals 4? How can we graph that? I thought we were talking about y equals mx plus b. Okay, let's take a pause. I was supposed to talk about this in the last video, but I didn't. So, there are 3 forms of equations. Of linear equations. There's slope-intercept form. Actually there are kind of 4, but slope-intercept, standard, point slope, and then there's intercept form. The star just means that it's not necessary, but still. Oh, I don't need to write it. Form. So slope-intercept form is a usual mx plus b. Standard form is ax plus by equals c. Point slope is y minus y1 equals m times x minus x1. Intercept form is kind of like standard form, so we'll talk about that. So now slope-intercept is what we learned, right? M equals slope, B equals the y-intercept. Ax plus by equals c. Okay, so what we see here is so we can make this into intercept form by doing minus ax and over b, right? So that means that, hold on, so negative a over b is the slope. The intercept, so the y-intercept is where it crosses the y-axis, and the x-intercept is where it crosses the x-axis. So now negative a over b is a slope. Then what else is there? So yeah, x-intercept, y-intercept. So if we set x equal to 0, then we'd have the y-intercept, right? So that means that c over b equals y-intercept. And then c over a equals x-intercept, because the x-intercept is where y equals 0. So if y equals 0, we'd have ax equals c, so ax equals c over a, right? Now, point slope, this one is, I like this one a lot, actually. So x1 comma y1 is a point, m equals slope, and that's it. So if you had 3 comma negative 4 at the point, you just plug those in, and then you can also find the slope or something, and you can, if you know the slope, you can do that. So nice. Now intercept form, it's kind of like standard form to 1. Okay, that's simple. I think so, right? Okay. So those are the 3 forms, and now we're gonna talk about this. So 3x plus 2y equals 4. That's our standard form. So we have 3x plus 2y. So that means that when y equals 0, we have x equals 4/3. And yeah, fractions, I don't like them. We're gonna just derive it. So we have y is equal to negative 3/4 x sorry, yeah, so I was just thinking. So we have negative 3/4 x, wait, what? Minus 3, sorry, negative 3/2 x plus 2. Okay, we know that slope, so the y-intercept is 2, negative 3/2. So we go negative 3, then we go up 2. Negative 3, up 2. We can also go positive 3, down 2. Positive 3, down 2. So yeah, there you go, that's the line. Now the next line is, we can solve for y, that's equal to negative 5/4 x plus 3/2, I think, right? Minus 5/4. Okay, yeah, okay, good. So now we graph that, we get the y-intercept is 3/2, which is 1.5, so right there. And then down slope is different, so it means they must cross somewhere. Negative 5/4. So negative 5 fourths means we go negative 5 up 4. Wait, sorry, no, we go down 5. To the right 4. Right there. Now, obviously, these are getting farther and farther away, so they must cross up from above the y-intercept. So we go instead of down, or instead of down 5, right 4, we go up 5, left 4. So up 5, left 4, right, because it's the opposite. And then we notice they cross here. And if we are, this is a really sloppy graph, so we can't really see it, but if I were to draw this a lot nicer, you'd see that they cross at 2, negative 1. They should cross at 2, negative 1. It's just my sloppy graph. But yeah, and that's what our answer is. The thing with graphing is to be really precise. Now, there are some special cases. Two systems of equations cannot have a solution if they're parallel. Because if they're parallel, they never touch each other, right? That's when graphing is good. An example is, so that means that the one equation is a multiple of the other. So we have, let's say, 3x plus 2y equals 4, and let's say 6x plus 4y, so we're multiplying by 2. Let's say, but we're not going to multiply in 2 both, otherwise it'd be the same thing. So this is equal to 9. If we were to graph them, we'd know they're parallel, so they wouldn't work. But because we're not going to graph, we're going to use one of our better methods, in my opinion. We're going to multiply by 2 on this first one, and we're going to use elimination. So we're going to have 4x plus 4y equals 8. And we're going to have 6x plus 4y equals 9. We subtract it, we get x equals 1. Wait, what am I doing? So we have 4x plus 4y equals 8. Okay, 6x plus 4y equals 9. Subtract, we get 2x equals 1. So x equals 1/2. Now we plug in that into one of the other equations, and we get so we get 1 plus 2y equals 4. So y equals negative 3/2, I think. But like if they're parallel, they just never touch, so don't work. There's no need to explain all this. Now, cool. So that's it for this video. Thanks for watching. See you later. Bye.